Long short-term memory networks and RNNs. How do they work? Bidirectional LSTMs are an extension of traditional LSTMs that can improve model performance on sequence classification problems. In problems where all time steps of the input sequence are available, bidirectional LSTMs train 2 instead of 1 LSTMs on the input sequence. The first on the input sequence S's and the second on a reversed copy of the input sequence. This can provide additional context to the network and result in faster and even fuller learning on the problem. Bidirectional LSTMs. The idea of bidirectional recurrent neural networks, RNNs, is straightforward. It involves duplicating the first recurrent layer in the network so that there are now 2 layers side by side, then providing the input sequence as input to the first layer and providing a reversed copy of the input sequence to the second. To overcome the limitations of a regular RNN, we propose a bidirectional recurrent neural network, BRNN, that can be trained using all available input information in the past and future of a specific time frame. The idea is to split the state neurons of a regular RNN in a part that is responsible for the positive time direction, forward states, and a part for the negative time direction, backward states. A simple overview of how RNN and LSTM works. Implementation on Bi-LSTM in time series data. Let's get into example code. Import numpy as np, import pandas as pd from sklearn.model_selection, import train_test_split from sklearn.preprocessing, import minmax scalar from tensorflow.keras.models, import sequential from tensorflow.keras.layers, import LSTM, bidirectional, dense. Dataset loading data equals pd read_csv/c:/users/sir uj_colon/desktop/data.csv data. Dropping unnecessary columns like slno and from date data equals data.drop columns equals slno, from date hashtag replacing nan values with 0 data.filna, 0, in place equals true, hashtag dataset has columns for features and a target variable feature_columns equals pm10, no2, NOx, NH3, SO2, CO, ozone, benzene, F-benzene, MP xylene, WS, WD, SR, BP, at, RF target_column equals PM2.5. Hashtag splitting the dataset into features and target variable x equals data feature_columns.values, y equals data target_column.values. Hashtag normalizing the feature values scalar equals minmax scalar, x_scaled equals scalar.fit_transform, x. Hashtag sliding window parameters window_size equals 5, hashtag number of past time steps considered output_size equals 10, hashtag number of steps ahead used to predict pollutant concentration. Hashtag create 3D dataset using sliding window technique, def create_dataset, x, y, window_size, output_size x_windowed equals y_windowed equals 4I in range, len, x, window_size, output_size plus 1 x_windowed dot append, xii plus window_size, y_windowed dot append, yi plus window_size I plus window_size plus output_size, return np.array, x_windowed, np.array, y_windowed, x_windowed, y_windowed equals create_dataset, x_scaled, y, window_size, output_size. X_train, x_test, y_train, y_test equals train_test_split, x_windowed, y_windowed, test_size equals 0.2, random_state equals 42. Hashtag build the bidirectional LSTM model equals sequential, model.add, bidirectional, LSTM, units equals 50, return_sequences equals true, input_shape equals x_train.shape1, x_train.shape2, model.add, bidirectional, LSTM, units equals 50, model.add, dense, output underscore size, hashtag output layer with output underscore size neurons for multi-step ahead prediction model.compile, optimizer equals atom, loss equals MSE. Hashtag train the model model.fit, x underscore train, y underscore train, epochs equals 100, batch underscore size equals 32, validation underscore data equals x underscore test, y underscore test, verbose equals 1. Hashtag evaluate the model loss equals model.evaluate, x underscore test, y underscore test, print, f test loss, loss, hashtag make predictions equals model.predict, x underscore test. From sklearn.metrics import mean underscore squared underscore error, r2 underscore score import ib.stats as stats hashtag calculate fraction of predictions with a factor of 2, fac2, def fac2, y underscore true, y underscore pred within underscore factor equals np.abs, y underscore true slash y underscore pred, equals to return np.mean, within underscore factor, hashtag calculate root mean square error, rmse, reams equals np.sqrt, mean underscore squared underscore error, y underscore test, predictions, hashtag calculate correlation coefficient, r equals np.percoef, np.ravel, y underscore test, np.ravel, predictions, 0, 1 hashtag calculate mean gross error, mge equals, np.mean, np.abs, y underscore test, predictions, hashtag calculate mean bias, mb equals np.mean, y underscore test, predictions, hashtag calculate coefficient of efficiency, co equals 1, np.sum, y underscore test, predictions, 2, slash np.sum, y underscore test, np.mean, y underscore test, 2, hashtag calculate coefficient of determination, r2 score, r2 equals r2 underscore score, y underscore test, predictions, hashtag print the evaluation metrics print, f fraction of predictions with a factor of 2, fac2, y underscore test, predictions, print, f root mean square error, rmse reams, print, f correlation coefficient, rr, print, f mean gross error, mge, print, f mean bias, mb, print, f coefficient of efficiency, coco, print, f coefficient of determination, r2 score r2. Thanks for watching. Stay ahead. At play.